Before we touch a single setting today, I want you to answer a question in your head. How long does this impact actually take? Think about what that actually means for an explicit analysis. Most of the time in an explicit analysis, we are talking about microseconds. So if your real event only takes 5 milliseconds and you tell the solver to run it for a full second, you are burning enormous amount of compute time simulating nothing. The ball already bounced off. There is no more story to tell. So the first engineering decision in this whole segment isn't a software click. It is an estimate of how long does this event physically last, and also there is the energy conservation. Now, when we talk about the energy conservation here, we are talking about total energy. If nothing external is pumping energy into the system, kinetic energy converts into internal energy as the plate deforms. Some of it springs back. If that energy curve starts doing something strange, climbing when it shouldn't, that is your model telling you something is physically wrong before you have even looked at the stress plot. So now, with that in mind, let's talk about what we are actually configuring. The first thing we are configuring is the termination time. This just tells the solver when to stop. The second thing we are configuring is the binary D3PLOT or the output. This is your result file containing stress, displacement, everything you will actually look at visually. The third and the last thing is optional, but I'll advise you to do that because we are going to do that in this episode. And we are going to turn on the GLSTAT and the MATSUM. GLSTAT gives you the whole model energy history. And when we're talking about the energy history here, we're talking about the kinetic, internal, hourglass, etc. While the MATSUM breaks that same energy down per part. And that second one is diagnostic goal, because if your plate shows almost zero internal energy while the ball has all of it, that tells you your contact isn't actually transferring load, no matter how correct it looks back when you set it. Now we are going to get into it and we are going to build it. So inside our LS-DYNA, let's open here. You are going to FEM, model and part, keyword definition. Now, here's the keyword definition. If you can't see anything, you just click on collapse all. Now, I'll change from the model to the all keyword, and I'll open the control card. Here's the control card. Double click or open it. Now, we look for termination. Look for termination. Here's termination. You double click on termination. Now, on termination, there is the end time, termination time mandatory. There is the DT minimal. Now, for this analysis, I'm going to use the DT minimum. Let's say if I'm running the simulation for 1 second and I come at the level of the DT minimum and I place 10, it will mean that the solver will be analyzing every 0.1 second, and that's what I'm trying to capture. So in this simulation, I'll be going for a default time of 1, and I'm going to enter 10 here. Okay, and I'm going to accept. Done. Perfect. Now for termination time, we are good. Still under the database. Here's the database. We double click. We are going to look for the S key card. We are going to look for the binary D3PLOT. This is it. We're first of all going to look at the binary D3PLOT before going to the S key card. We are going to enter the different energies, the GLSTAT and the MATSUM. So here we are going to give a DT of the time interval between outputs of 0.1. This is what I'll give, I'll accept, and done. Now we are good. Now we move to, we are going to look at the ICCII option. We are going to open it. We double click on that. Wait for it to open. Okay, now it's open. That is the default DT. And inside this default DT, we are going to check the GLSTAT card, the MATSUM, and the GLSTAT card. Okay. Now we are good. Can accept it and done. Okay. This is all for our simulation for now. And now before we end with anything, we are going to first of all start with the model check. That's what I usually do. You start with the model check. So I'll go on for the model check. Give it some minute for it to analyze. This is the element quality check. Let's go to the keyword check. Okay. At the level of the keyword check, there is no issue. I cannot see any warning. I just see, but that one can launch without any problem. The shell, I think it's normal. So there is no error. So you can just click on done, and we are good. Now I'll go to done. Now I'll go to file, and I'll save as keyword. Browse. Okay, I'll call it. We're coming back to our ball plate impact analysis folder. I'll call it ball plate impact. But instead of putting out, I'll put final one, and no, wait. It's looking for folder. Save it here. Select folder. Okay. Okay, analysis, final, and save. Okay, perfect. Now let's try to run our simulation. Run LS-DYNA. Now LS-run is open inside the computer, and the first thing you're going to select is the input. You're going to select the file, ball plate impact analysis final. You're going to select it. The solver, you're going to select the solver, and you're going to select the number of CPUs. Now, for my computer, I'm going to use 2 CPU for this problem, and I'm going to set the memory to auto. Feel free to use either 4, 8, or 16. It depends on the number of computers your CPU has. Now, at the level of the expression, leave it default. And since I already have the result file inside my computer, I'm not going to launch it anymore. But if you want to launch this job, just come and click it here, and see you in the next episode.